Hello, and welcome to a deeper dive into analyzing your body composition scan. My name is Dr. Sandi Buheister, and I am the owner and founder here at Pivotal Connections. So first of all, I'm going to have you make sure that you have 2 pages from your full body composition analysis. One is going to have a black and white skeleton in kind of the upper left corner. And the second page should have a side-by-side image, one a kind of a yellow to pink to blue scan of yourself, along with another black and white image that is not skeletal. We are going to start with the image of the skeleton, which is actually a DEXA analysis of your overall body, full body, kind of a snapshot of your bone health. We're going to start on that page. So on the very, very top, you should say Pivotal Connections, 860 G Street, Arcata, California, 95521. And then below that, a long yellow bar. That is information that you gave us, along with us issuing a patient identification number. It should have your name, your patient ID, your date of birth, sex, ethnicity, height, weight, and age. If for some reason any of that is wrong, please let us know. Below that, you should see, of course, that black and white skeletal image of yourself, and then the scan information to the right of that. The date, the type of scan, the analysis of what was used, the operator, the model number of this DEXA scanner, which is a Horizon WI, and any other additional comments that we have made. Below that, you will see a larger yellow box that says DEXA Results Summary. In this box, you are going to see regions, area, bone, BMC, BMD, T-score, and Z-score. I'm going to dive deeper into each of these. In that yellow box, there are regions. You'll see both of your arms, both sides of your ribs, your T-spine, which is kind of the middle of your back. Your L-spine is your low back. Your pelvis is very low on your spine, kind of where your hips and your legs attach. And then both your legs, along with a subtotal, adding your head, and then a total. Each one of those regions, it's going to go through and give you area, which is the next column. That is literally the area of what your bone is taking up, like the actual area that it is taking up in each of those regions. Then the next column is bone mineral content, or BMC, and so that is the weight of the bone in each of those regions. The next one is then taking the grams per centimeter squared, which gives you your bone mineral density for each one of those regions. It should be noted that this is a lot of information, and the majority of these numbers, most people are not super curious about. However, some of you are, and therefore you have them right in front of you. But the next 2 columns are where the more important numbers come from. So you're going to see a T-score and a Z-score. So let's dive deeper into those. What this whole analysis is looking at is what your bone mineral content is compared to 2 other populations. And that's what's happening for the T-score and the Z-score. For a T-score, it is comparing you to a young normal population. Young normal meaning at the time when bone mineral density is at its greatest amount in your whole entire life, and that's usually about mid-20s. So it is comparing your current score on the date of this scan to a large group, a large database of a whole bunch of other people's scans that are in that young normal population. Then the Z-score is comparing your scan from the date of that scan to an aged matched population. So your score compared to a whole number of people in the same exact category, age matched, as you are right now, or as you were on the day of the scan. So the difference being what it's going to take is the standard deviation from normal. So the difference is, one, it's comparing to a young population, and one, your current population. T-score is what is used for diagnosis, but not necessarily from this type of scan. And I'll get to that in a second. So if you look in the lower left box, if you are over a certain age, it's going to give you on the right axis, it's going to say T-score. If you are too young and that comparative population doesn't make sense to compare you to, then you're going to get an age match score, which will say a Z-score. So regardless of that, in that box, the color coding is the same. So green means that your bone mineral density is good. That yellow band in the middle means you are osteopenic, and then the red at the bottom is osteoporotic. So somewhere on that, you should find a little hash mark that is a white dot. That is your current bone mineral density in either compared to a T-score or giving you a T-score or a Z-score. And you'll find yourself within kind of brackets of 3 lines. So if you're in that green, great. Your bones are healthy and you need not worry. If you start to fall into these yellow and these red ranges, then you should kind of be aware that your overall snapshot of the bone of your whole body is not as good as it could be. So the older you are, the likelihood of your bone mineral density to start to decrease is higher. So those 3 lines show kind of the average along the high end and then the low end, with the middle line being average for the general population. As you can see, that general trend as those lines move to the right, it's common for bone mineral density to start to decrease. So you want yourself to be in the green and as high above or at the average for your age. So let me know if you have any other questions about that, but that is the gist of this page. Some additional information that might be helpful are the actual numbers. So you're going to see your T-score as a number, a low number, and then as possibly a negative, and your Z-score also as a low number, possibly negative. So this goes by standard deviations of normal when you're comparing to that whatever population you're being compared to. So for a T-score, which is what is most commonly used for diagnosis of osteoporosis and osteopenia, we are looking for anything above -1. -1 and higher puts you in the green. -1 to -2.5 puts you in the osteopenic range, which is low bone mineral density. And then -2.5 and lower puts you in the osteoporotic category. Now let's take a look at the second page, the one where there's 2 images of your body. One image is like color coded, and then the other image is black and white. So on that page, again, similarly to the previous analysis with the bone mineral density, that long yellow box at the very top should match the same information as the previous page, and then of course match you, patient name, name, patient ID. Now in some cases that patient identification line might be blank, and that's totally okay. Your date of birth, sex, ethnicity, height, weight, and age at the time of the scan. If any of that information is wrong, reach out and please let us know. So let's look at those 2 images over on the left. One is just kind of a negative space image. You'll see kind of 2 areas just below your neck that are open, that's actually your lung space. And then, some density, kind of goes by density of the rest of your body. But the one on the left, where it shows an image, there's a gradation scale at the bottom that says fat, lean, bone. Fat is kind of yellow, shades into orange. Lean tissue is kind of this pink, deep purple. And then, of course, bone is a very bright blue. So that is kind of a cross-sectional image of your body. So you can see where some of your fat is located, where the lean tissue is, and then, of course, bone. The next box on the very top shows a chart. It says total body fat percentage, and then a dark blue line on the bottom, and then a lighter blue line on the top. And somewhere in and around there, you should see a little white circle with a hash mark in the middle, or a cross in the middle. And that data point is you. So this is body fat percentage. So you can see by age on the bottom, body fat percentage on the left, and kind of the average in between. So if you are above in the light blue, that means you have above average body fat percentage compared to an age-matched population, because see the Z-score on the right side, that tells us it's age-matched. And then if you're below that, that means that below the changing of those colors, then you are lower than the average percent body fat for your age. Now, going underneath that, you are going to see kind of a purple to an orange with green and yellow or light orange in between. This is the BMI. Now, on previous videos, if you watched anything from the DEXA University that we have listed, it should also tell you that this is a pretty terrible descriptor for categorizing the human body, because what this does is simply goes by two factors, height and weight. If you are a very short, muscular person, this is not going to fare well for you, because it's probably going to tell you you are obese. And then opposite so. I'm not exactly sure why the medical community seems to use this, but it is not designed for the athletic population. Typically, this is for the very sedentary population, somebody that does not get any regular exercise. But if you exercise 30 minutes 3 times a week, then this is not for you. So ignore that for the most part. Okay, now at the very bottom of this page, kind of the bottom third, there are 3 yellow boxes, 1 to the left and 2 to the right. Let's start with the one on the left. Now, I always joke, and you may have heard me say, this is kind of the meat and potatoes of this whole scan, because this tells you your whole body composition results broken down by region. It gives you total fat in mass, which is in pounds, your lean tissue and body mineral content in pounds, total body mass in pounds, body fat percentage by each of those regions, and then a percent fat percentile based on those 2 populations that I had talked previously in the bone mineral density, the young normal and the age matched. Now, the couple of things to mention here. So if you look at kind of that obscure, not obscure, but that the black and white image on this same page where you can see your lungs, you're going to see a couple different boxes written in a very light blue. It's going to have an A, a G, and a VAT box. Now, in this yellow box that we're looking at, you're going to see at the very bottom it says android with an A next to it and gynoid with a G. Those are just additional regions that the DEXA scan has analyzed and given you the fat, lean tissue, mass, and body fat percentage for those regions as well. And I'll mention and I'll get back to the VAT in a moment. So this left lower yellow box will by region give you again the fat mass, the lean tissue and bone mineral content, total mass, percent fat by each of those regions, which is a ton of information. And if you have any additional questions, I highly recommend a quick Google. And if Google doesn't help, then you let me know. Let's move on to the adipose indices. So adipose tissue is just a fancy word for fat tissue. So you'll, on this line, or in this box, you'll see the total body fat percentage, which should have carried over from the left yellow box to this right upper yellow box. And then there are other ratios and analyses underneath it. Again, probably more information than most people need, but there's a couple key things that should be seen here. So the BMI I talked about as not being great, but there's this fat mass index underneath that total body percent fat. It says fat mass by height. This is a kind of a more important number, and in comparison to the percentiles, you want to be lower, and under that YN and AM, you want to be lower in the percentiles of each of one of these. So as you go down, the android and gynoid regions, there's going to be a number. It's going to be something point something. This is comparing the android region and the gynoid region, which I talked about are that little A box and that little G box. And this is an indicator that many medical professionals will use to predict cardiovascular disease. 1 and higher is an indicator that the person probably has closer to an apple body shape instead of a pear. And those people tend to have higher risks of cardiovascular disease. Below 1, then people are at a lower risk, and that tends to describe more of a pear-shaped population. Moving down, I want you to take a look, moving down in this yellow box, take a look at the estimated VAT, and you can see there's a little, on the very bottom in the white, it actually shows what some of these abbreviations stand for, but that is VAT, is visceral adipose tissue. And if you go back to that kind of dense image where it shows your lungs, you're going to see that little VAT box. That is where these analyses are coming from. And this is where it's taking your visceral adipose tissue and telling you how much fat you have in and around your organs. Now, VAT mass is listed here in grams. So I want to talk about how you can convert your visceral adipose tissue in mass, which is given to you in grams. First of all, you can just Google a quick grams to pounds conversion, which is super easy to do. But something to put in your head is about 1,000 grams is about 2.2 pounds. A quick conversion, therefore, based off of what your number is, you can kind of try to figure it out. Otherwise, just Google that conversion, type in whatever your number is for grams, and it'll convert that directly to pounds. That way you can have a kind of a better idea. Then the VAT is given for volume and area. And again, just great information. This one is kind of more fun to look at if you are anticipating making a big change in your body composition. Then you can kind of see and watch how that VAT changes. Moving down to the smallest of the 3 boxes in the lower right hand corner, we're going to talk about lean indices. Now, lean indices just talks about lean tissue. The one of these numbers that is more important and most important is this Appen lean/height, which is your appendicular lean tissue in your arms and your legs compared to your height. Now, we want this number to be as high as possible. And I'm going to put up a chart that shows what is considered normal, low muscle, et cetera, et cetera. You can take that number and you can compare it. This is a chart telling you what your risk factor is for developing something called sarcopenia. Sarcopenia is a muscle wasting disorder that is very, very common as we age, and you want this number to be as high as possible for as long as possible. So if you have a lower amount of muscle, a great goal would be to get more. Okay, so I'm going to move on to some of the percentiles. So on that lean indices, you actually want to be high. You want to be a higher percentile compared to a lower percentile for the lean indices box. But in the adipose tissue box, adipose indices, you want to be low. So you want to be high in the lean indices box and like 90 percentiles high, and then of course adipose tissue, you want to be low. Hopefully this deeper dive was helpful to you, and of course reach out if you have any additional questions that you were not able to find answers to yourself. And I look forward to seeing you scanning again in the near future.